Okay, so it's 6-5. This is video 120, and this is strictly an enrichment video. We've been encouraged to make videos on enrichment, and so I just want to do this one here. And some teachers would say proof. I'm going to avoid the word prove, and I'm going to use the word show that if a number is odd, its square must be odd. So why am I doing this? Because this shows you an application of polynomials that I taught you already. And I think it would be very instructive for those kids who want to get better in math to apply what you learned to a problem that makes sense. Well, first thing to do is decide if the problem makes sense. Okay? So I'll go over the words in the problem, go over some stuff we learned in elementary school, and then show that if a number is odd, its square must be odd. Well, what do we mean by number? Okay, so I'll go over here and I'll move this slightly over. Okay, we'll get to the other side in a second. And what do we mean by a number? Well, we're going to call a number any integer that's positive. Okay? So in math, it becomes very important to define the domain they're going to call it. We talked a little bit about that. But when we say number, we mean a positive integer, okay? And zero's trivial because 0 times 0 is 0, right? And we also are going to avoid negative numbers, although it works with negative numbers, just to make the basic point. So it says show that if a number is odd, its square must be odd. So the first thing you do is see if the problem makes sense. Does the problem make sense? Well, isn't 3 odd? Yeah. 3 squared is what? 9. So it works with that. Let's try another odd one, maybe a bigger number. How about 11? Just to, to test the waters out. And so what's 11 squared? Well, you're supposed to know that. That's one of your perfect squares. 121. So it follows instantly from this, if you take the square root of 9 and 121, you're going to get an odd as well. But they're not even asking you to show that. Okay? I'll try one more time. I'll try 13, just to make sure that, and 13 squared is 169. I say, am I sure? Yeah. 15 squared is 225. Things I learned in 8th grade. So it's, as far as I can tell, it's true. But is it true all the time? And that's what a lot of math does. Okay? So that's something you have to get used to. That's what a lot of math does. So I'm going to show, using polynomial math, that it must be so. It must be so. Okay? And so that's the whole gist about what I'm doing here. And we call it enrichment because we're applying what we already learned to a math problem, and we start to see why these algebraic expressions exist and why they would make sense. So we define number, we made sure the problem makes sense. We used a whole bunch of examples using our knowledge of perfect squares and squaring. And now we go back to elementary school, and you can do it in your head yourself. No one can deny that an even plus an even is an even. Okay? I'll just put an E there. But just do it in your head. You'll never come up with anything else. And an even plus an odd, this must be what? Just think about it. Do it any time in your head. 4 plus 3. 14 plus 5, you do it until you're tired, okay? So there it is, an even, an odd. And now we ask ourselves a simple question, what's an even times an even? Well, if you work it out in your head, it's going to be an even. 4 times 2 is 8, 12 times 12 is 144. Go on until the end of time. You'll see that that must be true. And any even number times an odd number must be an even number. 2 times 3, 2 times 5, 4 times 5, 10 times 7. You go on and on. You'll never find any exceptions to that rule. And finally, an odd times an odd must equal an odd. Just do it in your head. 5 times 3, 7 times 9, and go on and on. And so with this basic elementary math in our mind, let's see what's going to happen here, okay? So we need, in our math here, to construct an odd number. So I'll move this over here. So if 2 times an even, if an even times anybody is odd, then I can always construct an even number. An even number is 2n. It could be 4n, 6n, 10n, but it doesn't make a difference. 2n must be even. Do it yourself, okay? But an even plus an odd is odd. So there it is. I constructed an odd number. You plug in any number you can think of, and we said a number is an integer, right? And we decided to make them positive so it's easier to understand. And you'll always get an odd number here. So this defines an odd number, okay? So they say its square must be odd. Well, this is why I'm doing the video. Isn't this neat? I'm going to take what must be an odd number. You can work it out yourself anytime you want, okay? And I'm going to square it. Oh, that's the polynomial math we were doing. This becomes a perfect square trinomial. So we agree this must be odd. Experiment. Till you're tired of it. You'll see that it must be true. So we just have to show that if I square this odd thing, no matter what I put in here, I'm going to get an odd number. Must be the case. So let's do the math that we know already. After all, that's the whole reason. So that's 4n squared, and 1 and 2, so there's 4n. We told you to do that. And then 1 times 1. And so there we go with the f squared and the last squared, and the last squared here, and the o plus the I, all that stuff that we did before. And now I have a perfect square trinomial. And let's see what's going on here. No matter what n is, right? When I can square n anytime I want. It happens to be that an even squared is even. But it doesn't matter. Whatever I get here, since I multiply by an even, this must be even. No question about it. You can't deny it. For the same reason that the 4n squared is even, this must be even. You can't deny it. Just work it out. Do any numbers in your head. But an even plus an even is what? Even. But isn't 1 an odd number? So an even number plus 1, by definition, must be what? Odd. So this is what we call showing something in math, that I can pick any number I want, not just the examples I did before on the board. Let me move this over here so you can see what I'm doing. That it must work. And why did I show you this? Because we used a perfect square trinomial to show this. Okay? And of course, if you wanted to go the other way, which nobody asked you to do, of course, since 2n plus 1 squared is an odd number, right? Then the square root of that equals 2n plus 1. But we just explained to you 100 times on that side. So that means the square root of an odd number, if it's a perfect square, must be odd as well. But that just makes sense. So that's what I wanted to show you. That's an application of the math that you've been doing. And it's all, I'm just giving it to you one more time so you can look at it, what I wrote here. Okay. And there's the math that I did. And this would be something that a Regents kid would do maybe on the second part of the test, showing that they can apply polynomial math and perfect square trinomials to a common sense problem that we were asked to do. Okay.